Go on mute. So if you would make sure you're unmuted.
Good morning and welcome everyone. Hope you are enjoying the OCP Tech Week. Before I begin, I would like to express my sincere thanks for all the frontline workers and my prayers to those who are affected by COVID. It's hard to be not connected, be in person. I'm happy that we could at least connect virtually. Let's get into the SONiC model-driven APIs and FRR integration. So what you're seeing in the screen right now is the different management interfaces available in SONiC. So what we have is a native CLI. This is a legacy Python-based Click CLI available in SONiC. And we have SNMP provides a set of MIPS to monitor SONiC. It's little limited on read-only today. And then we have the config DB, which is a single source of truth for SONiC, which uses the JSON schema, DB JSON schema, to configure SONiC using the config load and reload command. And we have the legacy minigraph based approach. It's an XML file where you can use minigraph load command to execute. And then we have FRR CLI to configure the layer 3 protocols and BGP and VTOSH and Linux shell commands for some of the SONiC native CLIs, native Linux CLIs. So SONiC provides this disparate different choices for management of your network. The SONiC device itself, while different options are available, may look beneficial, but there are really some challenges involved. In our previous session, we talked about the challenges we faced. Config is one of the primary challenge the customers are facing today. So configuration model is not centralized. So the user has to switch between multiple different CLI, the click FRR, and the config JSON and all. And backing up the configuration also seems to be a challenge. Now we have to back up multiple varied configuration files in order to back up your source of truth. And teams have to learn different various SONiC command formats like click CLI, FRR CLI. And then it also needs a root privilege level to execute all these commands as well today. So with such challenges existing in the current management framework, there is a need for a comprehensive and centralized management framework. Dell Technologies and along with Broadcom and the community led the management framework in the previous release, which comes up with a new set of management interfaces for SONiC, which has an intuitive CLI and a REST API, which is Open API spec compliant, and a GNMI interface and a GNI interface, which is also compliant to the GNMI spec. And we have a SONiC Ansible collection, which has REST API southbound and provides you. So today, when we go to the customer, typically what they are all looking mainly at a config DB as their primary schema for their day 0 operation, and for day 1 and day 2, they typically use Ansible modules or the REST or GNMI related interface. On their troubleshooting piece, they use the CLI for SONiC. So we saw the various different Northbound interfaces available for SONiC. What we have on the model front. So SONiC has different models. The first one is the SONiC schema. This is a low-level JSON model or DB JSON model we talked about earlier, which uses config load and config reload commands to push the config. So this is primarily used in case of bootstrapping the device via ZTP, because ZTP today only takes the configuration via the config.db.json format. And then whenever you're RMing use case, you have to push the config again. You have to get the device back in the same state. So the saved config in the config.db.json being replaced in the new switch provides you the RMA use case as well. And then it provides us a backing up of config. So with the management framework, we're trying to unify all the schemas into config.db so that the user can just back up one centralized schema and then get back to it whenever they need back. And then coming to the next one is the SONiC Yang models. When we introduced the management framework, there was a strong urge from the community to create a SONiC native models apart from the open config models as well, because community was already used to this kind of model via config.db.json. So we have as part of the management framework, so we have created both the SONiC Yang as well as the supported the open config Yangs. SONiC Yang provides one-to-one mapping between the SONiC schema. So these are typically used to configure day 1 and day 2. As I said before, day 0 is typically done via ZTP with config schema. SONiC Northbound interfaces, the new Northbound interfaces, REST and GNMI, both supports the SONiC Yang models. So if you want, you can take an OpenAPI spec and create an SDK for you based on the SONiC Yang model as well. And the next one is the SONiC Open Config Yang model. So SONiC supports the Open Config Yang models. So this is also supported by both REST and the GNMI when you want to configure the device. The main reason for going for a standardized MIB is to leverage the existing standard tools available in the market, so that people who want to interact with it, it's easier. It's a standard-based model. That's the reason we went with the Open Config standard, and primarily it is driven by the user community, right? Who are using the Yang model. So that's where the Open Config origin is. So that's the reason we started supporting that as part of the management framework. So now you can use the standard tools like YDK or ONAS controller, right? Currently they're using for the Stratum, they're using the GNMI based open config models to provision the Stratum. So the same thing can be leveraged by a little bit fine tuning the existing standard tools. And we are extending open config. As everybody knows, open config is not fully complete yet. So we are extending the open config models to add the missing features and functionality. We are working with the open config community team to upstream those models as well. Ansible, starting Ansible 2.9, if you're familiar with Ansible, so they had their generic modules earlier, then they came up with the roles. Now they are into the network resource modules in order to get an unified model to go across all the different vendors. So SONiC supports the Ansible resource modules as well. And we have published a SONiC collections to Ansible Galaxy, which can use to configure SONiC. This leverages the open config REST API underneath. And whatever models which are not available in SONiC Ansible resource modules, we are contributing for those models as well. So these are the different models available today for SONiC. We have seen the Northbound interfaces. I just want to take a couple of moments, even though we have gone through this before in our earlier presentation. I just wanted to showcase the 3 new interfaces with the management framework in order to address and enable easy migration of the enterprise customers, right? So as long initially SONiC was deployed in the cloud, where people are using all this API kind of framework for a big cloud environment, right? When we go to the enterprise market, people are still familiar with CLI. And then there was a struggle in adopting SONiC because SONiC's CLI, it's not directly known to them, right? So the management framework brings back the intuitive CLI, which they already know, to SONiC. So it uses an open source CLISH framework to accomplish this, and it uses REST southbound models to configure the SONiC. So as you can see, we have taken a step to integrate the FRR CLI as well into the management framework. The HLD is already available. The pull request for code is also available. Vengat will shortly walk us through on how they have integrated FRR into the current management framework. As you can see, the BGP commands which comes here as an output, you can see that it's your familiar BGP configuration which you have used to. Yeah, this is one of the modern and cool interface SONiC provides, the REST API, right? Even if you today, whenever I go to customers and talk about it, they're really feel pretty amazed by looking at the online documentation which SONiC provides with the REST API interface. Even the traditional NASs today, even today, they don't have this kind of capabilities. I've seen 1 or 2, but the entire thing is completely managed via the model-driven telemetry and provides this API online documentation for them to play around. So basically, you can go to the HTTPS and your management IP and UI, you will be landing up to all the models which is SONiC is supported. So you don't have to look somewhere else to what models are supported in this version. You'll get the entire model right there. And you should be able to play around with the REST interface right there. So you can log in and authorize and get a token, or you can use your username and password. You should be able to try out any REST APIs you have. So you can download the YAML files, which are nothing but the OpenAPI spec, You can put it in your Postman collections, or there. Otherwise, you can use the Open API tools today and take the Open API spec and then generate the SONiC SDK with your language of choice. We have seen customer build their own orchestration engine by using the Open API spec, which is provided along with the SONiC. And then all this Open API spec is also derived directly from the Yang itself, right? So there is no manual thing. So when a SONiC developer develops a feature, he defines a Yang, and then the entire spec as well as the REST API backend server code, everything is automatically generated. The same API spec can be used for the customers to generate their client-based SDK as well. SONiC also provides a more modern interface, the Google's network management interface and network operation interface, which supports both configuration as well as streaming telemetry. It is compliant with the GNMA spec as part of the management framework. Previously, there was only a subscribe part of it. Now we have the entire set, get, and capabilities, everything implemented as part of the framework. And then we also recently contributed to a SONiC GNMA Telegraph plugin, which is already in the pull request. So you should be able to, out of the box, deploy a SONiC box and then configure the GNMA based telemetry to visualize in your Telegraph Grafana stack. And we also recently introduced the GNOI framework. This is the network operation interface from Google. We have put in the framework, and we have currently supported few RPCs for managing the image management, tech support, and other stuff. So we'll be enhancing this framework soon to support other operational parameters like trace route, ping, and other stuff. Currently, on-chain streaming is still in development. Hopefully, once that capability is available, we do have on-chain in the framework itself, but actually supporting that for the few of the objects is still in on works. So once we have that, so now you can quickly react to whenever a BGP session goes down or MLAG session goes down, you'll immediately get a notification rather than you waiting for an event to process those things. Right. I think with that, hopefully you got a better understanding of various SONiC management interface and SONiC management models available. Pick your choice and happy SONiC. So I'll transfer to Venkat to go through the FRR integration with the management framework.
Sure, Sendil. So as Sendil mentioned, we have two main requirements from customers. One is to unifying the FRR protocol configurations as part of config.db JSON, and then providing the Northbound interfaces, CLI, REST, GNMI for protocol configurations. So as part of the unifying the FRR protocol configurations, that is to have a single source of truth part of the config.db JSON. We looked at the SONiC solution. We found different config types. For example, separated, wherein we have individual features, config files, and then unified. We have single FRR conf, wherein we have all the FRR commands. So, but the default config type supported is separated. So we wanted to retain that separated mode with all the individual protocol feature specific configurations files. And we also observed template-based configurations today with minimal configurations from config.db, and rest of the configurations are assumed in a template. Basically, the route map, BGP peer group, address family configs, and those things were assumed in the template, and were pushed to FRR for a specific use case. So what we wanted to do was, like, we wanted to enhance the we want, because the template based configurations are not suitable for customers, because those are not generic enough to handle different customer use cases. We have decided to enhance the existing infra by defining various config schemas that were actually missing in SONiC today for various protocol configurations. Example, BGP, OSPF, static routes, etc. The enhancement done in BGP Conf-D, which is part of BGP containers, are basically one to handle the new config.db events, and then converting those events into appropriate FRR commands, and then caching those events to avoid any duplicate configs pushing to FRR, and then having the BGP connected socket to update the FRR via socket instead of the cell command execution, because the cell command execution was taking more time. So we, in order to optimize those executions from BGP config perspective, we have added, we have used the BGP client socket readily available as part of the BGP container. So we have also enhanced the Jinja templates to convert the BGP config DB. The BGP configs are present in the config DB into FRR configs to apply them into FRR during BGP container restart or the system restart. This is for the first requirement, basically the unification of the FRR protocol configurations part. So as Sendil mentioned, in order to support the various northbound interfaces for FRR protocol configurations, we picked open source glitch framework for CLI, and then the standard open config models, and then wherever the gaps that are there in order to support extended BGP configuration, we have extended with additional lists, tables, and stuff like that for REST and GNMI interfaces. For CLI, so we converted CLI commands into REST configurations internally. So from management framework, translib or transformer perspective, we'll be handling the REST records from Northbound user, and then we'd be doing the various validations using CVL library based on Yang models. The FRR SONiC models are based on new config DB schemas. Since these configs are validated as part of CVL, we would be there won't be any FRR configs errors when we execute those commands from the BGP confd. So in the configuration sequence, we have user config. So the northbound user could be from CLI, REST, or GNMI. So we would be getting the REST config request in the backend. As I mentioned, there would be the transformer methods due to various validations, and then the before pushing it to the config DB, we would be doing the additional checks based on the SONiC Yang. Basically, there might be dependencies like the leaf refs and other dependent config should be present in order to push those configs to config DB. Otherwise, there would be an appropriate Yang errors will be returned to the user. The user will be able to correct the configs and then re-push with the right dependent configs. So, and then once the config is pushed to the config DB, there would be Redis DB events generated, and the BGP config is has been enhanced, to handle various new config DB events, and then to convert cache them, and then to convert them to equivalent FRR commands. Next slide. The source sequence for the config information. So the Yang has if you take the open config model, has various the parent containers, siblings, with each with the config and state containers, right? In order to populate the config information for get operation, we would be there would be a request from the northbound user, and then the translib or transformer, which is part of the management framework container, would be querying the information from config DB, and then populating those information in an Yang data format, and then we'll be returning to the user. And it's up to the user to beautify those configurations either through the Jinja thing, or they can use the any JSON formatting and stuff like that. So those things are flexible to the user. Next slide. So with respect to state information, the state informations are available in FRR. So we have enhanced, as I mentioned, we have enhanced the BGP client socket to have the to execute the FRR commands directly, and then we'll be getting the information in JSON format. There were few enhancements done in VTSH command to fetch the state information in JSON format, and then we'll be converting those JSON information in a Yang data format, and then we'll be returning to the user. So from user perspective, they'll be getting the various BGP session state and statistics and stuff like that, and then they can basically convert those data, raw data into JSON, or you can beautify with JSON templates, Jinja template and stuff like that. They can, the user can very well do with that. Next slide, Sindhil. So this would be covered by Sindhil.
Yeah. Hey, thanks, Venkat. The call to action for you all is join the SONiC management working group and voice your concerns as well, right? So as in we go, we are taking SONiC to the enterprise, to the service provider network. So the more and more use cases are coming from those areas. So voice your concerns on the management subgroup, so that what direction you want us to take, and the HLD is already available for you for review, and then even the code has been submitted, the integration code has been submitted in the pull request, so you can find those links in the slide set. And the request to the developer, SONiC developers, is when you are adding a new feature, please add it via the management framework, so that going forward, this could be a one-stop shop for the customers as well, to maintain a single source of truth for SONiC. Everything comes via the config.db.json, so that they can use that for backing up on as a single source of configuration truth, right? And when you provision the management framework, use the provision the SONiC, use the management framework, the options available, the new Northbound interface available to you, so that to avoid any misconfigurations prone to the previous legacy configurations. That's all we have. We are happy to take any questions you have in the chat. Let me open up the chat. If you don't have any questions, I think we are good.